Hi, this is Tony Vinton. I'm just going to go over some of the main things that I think you should focus on in Module 1. Basically, things that I've noticed that students have had trouble with in the past. And this is going to help you just to kind of be mindful of that as you're doing the homework and the quizzes. So in Module 1, I really only have a few things, and it's really just from sections 1 through 3. 4, 5, 6, and 7, definitely people do have questions, and I may post another video later. But for now, I'm just going to post some information, just some information from sections 1 through 3. As a reminder, your due date is September 7th at midnight, so make sure that you finish your homework and quiz by then. Of course, the homework has a due date of the end of the semester, so you can actually continue to work on your homework all the way to the end, and that's to help you improve your grade. But the quiz and the discussion assignments are going to be due on September 7th, so make sure to get it in by then. One of the things that I know that students have questions about, and this is going to be in section 1, a lot of times when it comes to graphing, so the graphing equations with the utility, students ask, okay, well, how am I supposed to graph if I don't have a graphing calculator? Now, the section itself offers a short tutorial if you're using a TI-83 or 84, which is totally fine if you have it. Again, those are not allowed for the exam. The exam, we're only using scientific calculators. Unless your instructor, because this video may be for multiple classes, unless your instructor has indicated otherwise. But if you don't have a graphing calculator, another system that we do use and that you can use at least for the homework and the quizzes is GeoGebra. So GeoGebra is free and it's online. You can get it basically anywhere. So you can get it on the Windows Store. It's actually also a web app. So if you just want to use the web or your browser, that's fine. But you can also use iOS or Android. It's a really great app, and it's good enough for what we do here in the course. So you can use either for homework and quizzes. For the exams, you will only be allowed a scientific calculator. So just to show you kind of how that works really quick, because the GeoGebra, there is a tutorial. Let me go down here a bit. It talks a little bit about how you would graph, for instance, this one, y equals 2x minus 20. And then sometimes you want to readjust your screen size to get a bit more precise. And there's a little kind of gear symbol at the top right. If you click on that, that's what helps you to navigate and make your window a little more viewable. I'll go ahead and bring up GeoGebra here as well. So in GeoGebra, notice I already have it up. Right on the left-hand side, you have your function to input. Right now, there's nothing here. If I just kind of go in a little bit. So let's say I want to graph y equals 5x plus 1. So I just type that in. And right away it gives me the graphs, and I can squeeze with my fingers. If you have a trackpad like a laptop, you can do the same thing. Or if you have a mouse, you can kind of scroll in and out. But again, you can also change your labels. You can change your lengths and distances, so your x-axis. Right now it says x-axis is 2.5, so it's automatic. But you can change that to a different one if you'd like. So for instance, right now, see how it's now the tick marks are at 2.5, but I could change that to 1 if I wanted to here, and this to 1. And it looks a little cluttered, but I can zoom in just a little bit. And sometimes that's good, sometimes that's bad. If you want to go back to automatic, that's fine. Usually the automatic is good enough. You can also graph it with others in the same screen. So if I want to graph x minus 1 or y is equal to x minus 1, it'll do that and can help you to find intersect points. We'll talk about that in a much later part of the module, so or the course. So anyway, GeoGebra is really great for just graphing, getting a sense of. You can also plot with points. So if you wanted to graph, I believe the point, let's say 0, comma 1, notice that it gives me that point, and that's point A automatically. If I want to graph 1, comma 4, excuse me, it does it automatically. So every app works the same, Windows Store, Android, or iOS, so you've got your choice there. Again, this is just something that we're offering to use. Again, for exams, you'll need your scientific calculator. So let's go back to our lesson here. So anyway, just a reminder of that. A lot of students have questions about that, and so I just wanted to offer a remind you of the different options you have. Another thing I wanted to talk about very briefly is the section that deals with linear equations with fractions. So the linear equations with fractions, that's going to be in section 2. So in that section, what you have, and what's different, I guess, from the other ones, is that you're solving equations where the x or the variable is on the bottom, right? So a lot of times when you're trying to solve those, the way to do that is you find the LCD. So notice in this first example, in example 3, that's what they do. They notice that they have 2x, 3x, and 3 there as your 3 different terms in the denominator. So in order for you to get rid of those terms in the denominator, or clear them, so to speak, they multiply by the LCD. So the LCD ends up being 6x. They multiply that through, and it makes the equation much easier to solve there. So it's something that you're going to notice when you solve. A lot of you I've seen in the discussions are doing just fine with it. However, there's been some questions about what happens when I get a solution and it doesn't work, even though it's the correct one. Something to be mindful of, and this is kind of stated down here at the very bottom, is that any solution that makes a denominator in the original expression equal to 0 must be excluded from the possibilities. That means that if you've got something on the bottom, let me come back to my example up top. If you've got a term, a value on the bottom that makes one of those fractions 0, we have to eliminate that as a possible solution. Notice in this case, if I plugged in x equals 0 into the first or second fraction, right, that would be a problem. It would make it 0 on the bottom, it would make it undefined. So we remove that as a possibility there. So it's not stated as much in this example, but it does state it in other ones. So notice here, they say that only one value is excluded from the solution set, and that's x equals 0. And the reason they're excluding it is because if you plug in 0, you get an undefined value. So again, that's just something to be mindful of too. So just be careful there. Other than that, though, I think these examples kind of paint a really great picture of what you're going to see in the homework. If you have any questions, of course, just post it in the discussion or send it to me and we can work it out. The last thing that I wanted to just share or talk about, and this is where students will have a lot of questions, is in the Section 3 homework, the models and applications. So I've just kind of looked at some of these, and I want to just like work out a few for you so that way you can kind of get a sense of how you would solve these. I'll start off by looking at the first one here. So notice here they're saying that there's a linear relationship, so that we know we're going to make a line. They even give us that line here. Let me start working this out to where I can draw a little bit better. So in this case, they have a scenario where they give you some data. It looks like the data shows that 4,000 shirts can be sold with a price of 123. Right, so they're giving us that right there. They also say that while 26,000 shirts can be sold at $57, so they're giving us another piece of information there. Those are basically points. Those are some x or xy values, or in this case they're using p and n values. So your different points here, right, for this one, you have a point of 4,000 and 123. Here you've got a point of 26,057. Notice that I chose the x value or the n value to be the shirts, and the P value or the Y value to be the price. And that's because they told us exactly what that was there, right? Notice here it says P is equal to MN plus B. So they're already telling us what they want to have the dependent variable and the independent variable there. So in that case, that helps. So if I find the solution or the slope, right, the M, because that's one piece I'm going to need, let me do that here real quick. So M is equal to y2 minus y1 over x2 minus x1. Now it doesn't matter which one you choose as y2 and y1 as long as you're consistent. Notice if I choose 123 to be my y2 and 57 to be my y1, then I need to choose x2 to be the associated one with 123. So then 4,000 minus 26,000. Okay. So when I plug that in and simplify, 123 minus 57, that's going to give me 66 on top. 4,000 minus 26,000, it's going to be negative 22,000. That does simplify a little bit. I mean, there is a 3 definitely in common, or excuse me, a 2 definitely in common with both. So I could say that this is equal to negative 33 over 11,000. And does it say anything about, yeah, so notice right here, it does say that they want us to round the slope to 3 decimals. So we should do that. So I'm going to divide. So 33 divided by 26,000, oh, excuse me, 11,000. And that gives me 0.003. So that's nice. So I've got the slope, M, and now I can plug this into a formula. So notice here I'm going to say P is equal to negative 0.003 times N plus B. And to find the B, because that's the other component they're going to want, I need to plug in either point. I can plug in 4,123, or I can plug in the other one. It honestly doesn't matter. I'll plug in the second. So this is going to be 123 is equal to negative 0.003 times 4,000 plus B. And now what I want to do is I want to find that B. So if I multiply that 4,000 by the 0.003, I get 12, or negative 12. So 123 is equal to negative 12 plus B. And then if I add 12 to the other side, that's going to give me 135. So then B is equal to 135. So I have now my B. So my answer here is going to be P, or they already have P, so I'm just going to say negative 0.003 N plus B, which is 135 there. So just kind of a helpful, process. A lot of these equations are going to deal with lines, so you do want to know how to find a line. And this process is going to repeat several times. The big thing here is finding the points. So notice that we do need to be able to identify what those points are. So let's look at a couple more here. Here, this is the same idea. They want us to find an equation and then answer questions about that equation. But in this case, I don't think they're giving us points. It looks like they're giving us, let's see. So they give us some information here. Oh, the world's current oil reserves are in barrels, so R equals to 1850. And they say on average the reserves are decreasing by 22 billion barrels each year. So notice in this case, if you want to think of it this in a terms of an equation, and they're saying an equation of R and T, right? So this means that the equation is R. Oh, I don't want to use that pen. The equation is R is equal to MT, let me write the t a little differently so it's different from the plus symbol, plus b. So we need to find the m and the b. What's nice about this one is they're kind of giving that information right away. So in this case, they're saying that the current oil reserves are 1850, which means that right at the starting point, or when t is equal to 0, the reserves are 1850, so that's helpful. But there they also give us the current rate. So they're saying that it's decreasing, so it's negative. So it's going to equal to negative 22 here, or m is going to equal to negative 22. So you can use both of these pieces of info to be able to answer, for one, m, and two, find the b, right? So I can say that r is equal to negative 22t plus b. And then from here, what I would suggest is plug in your 0 and 1850 to find the b. Oh, sorry. No, that's the one. So find the perimeter. So just a reminder, this is really a quick reminder. The perimeter, by definition, for any shape is the sum of all the sides. So in this case, if you have a rectangle, you can think of this as the length and the width. Probably better to write the longer side as the length and the width. So this is also length and that's also width. Then the perimeter is really just the sum of all those components. So W plus L, or simply put, this is 2W plus 2L. So they're giving us the components. So to find the perimeter, you're just going to plug in what your length and width are, and you're going to find that answer from that. Okay, so just to kind of remind you of what the perimeter definition, the basic definition is it's always the sum of all the sides. Okay, so I think that was the last one I wanted to look for. Oh, a lot of people do ask questions about this one, and I'll just set it up. So notice that they're telling us that they have a rectangular room is 6 meters longer than it is wide, and its perimeter is 24 meters. So let's see what that looks like here. So they're telling us it's a rectangular room, right? So let's draw a rectangular room. And it's got a length and it's got a width. So in terms of the dimensions, right, they're asking us to find this length and this width. We're only given some information. For one, they're talking about the perimeter, which we already know the perimeter is equal to 2L plus 2W. And they're saying that the room is 6 meters longer than it is wide. That's a big thing for us to be able to put together, because that they're giving us a relationship between L and W. So they're saying that if the width has a certain length, the length is basically 6 meters longer. So width is equal to 6 plus, oh, excuse me, let me go back a bit. Length is equal to 6 plus W. And that's really nice, because what I can do is I can take that and plug that in to this length right here. So that means that I can write this as, I want to change back to black. So P is equal to 2 times 6 plus W plus 2W. And then from there, they're telling us that we do have a perimeter of 24. So 24 is equal to 2 times 6 plus W plus 2W. Now, at this point, now this equation just has W. So I can solve for W, and then once I solve for W, I can go back and solve for L. So that's kind of my quick walkthrough for that, just to help you along. If you have questions, definitely post in the discussions to ask about this, and we can work it out more. That's it for now. I'm going to post a couple more vids later on today and tomorrow, just kind of some reminders about how to navigate through the course, because I've been getting a few questions about it. You know, I usually wait the first week because I know we're all kind of getting settled into it, but now that this first week and a half is in, you know, I want to make sure that you guys are all up to speed. So again, if you have any questions at all, email me or your instructor. Thanks.